Now that we have the form sheet created, this is what the metrics is going to look like. So there's going to be one card for every effect that we've identified. If we have multiple hazards or multiple effects, there's going to be multiple cards. First thing, it's going to give you information about what is the total failure rate. And you can click on this and it gives you some information as to where this is coming from. And essentially, it is sum of safety related failure rate and non-safety related failure rate. And simply, it's just the sum of all these components, failure rates of all these components. Gives you an idea of what is the overall probability of failure. Then we talk about what is the safety related failure rate. And this is calculated from the FMEDA, and we identify which individual failure modes can lead to a safety hazard violation and which ones cannot. So far, we've not identified anything else that cannot, but once that is modified, this value will change. Similarly, we have non-safety related failure rate, and simply safety plus non-safety is equal to total failure rate. Then we need to calculate the single point fault metric. So how is this calculated? There is a formula for this. The formula is SPFM is equal to 1 minus the residual failure rate by total failure rate. And in our example, the residual failure rate comes to this value. The total failure rate is 31, which is come from here. And then when you calculate this, it says it's 23.15%. Well, what does this mean, 23.1? What can we do with this? Well, in ISO 26262, depending on the ASIL, a certain level of SPFM has to be achieved. If it is an ASIL D, then an SPFM of 99% has to be achieved. Then we know that this is just not good enough, and we need to make some changes in the system to bring this up to a 99%. Similarly, we have a latent fault metric, and this is calculated using this formula: 1 minus latent failure rate by total failure rate minus residual failure rate. Again, what do we do with this metric? The ISO says for different ASILs, we need to achieve different latent rates. And we need to check if this is greater than or equal to what is recommended by ISO 26262. The final metric over here is the PMHF, or probabilistic metric for hardware failure. And in order to calculate this, the first thing we need to do is the system lifetime hours. So it could be, for example, if it is 10,000 hours, which is for a passenger car, it could be 10,000 hours. For a ground benign vehicle used in military standard, it could be even 20,000 hours. So that needs to be entered over here. Once this is entered, it is calculated using this formula, which is sum of residual failures plus sum of detected DPF failures times the latent failure times the lifetime. The first term here represents what happens if there is a residual or a single point failure. And the second term here represents what happens if there is a multiple point failure. And you can see that the first term contributes to PMHF more than the second term. Now, what do we do with this PMHF? Again, the ISO 26262 talks about for different ASILs, what is the PMHF that needs to be achieved. So for ASIL D, the PMHF has to be less than 10 fit. So we know that now overall probability is 23 fit, which is not less than 10 fit. Now we need to do something to decrease this fit, either by choosing different components or by increasing the diagnostic coverage. So the goal now is, now that we know the SPFM, LFM, and PMHF, we need to go back to the form sheet and we need to modify what safety mechanisms we have. Maybe we need to add more safety mechanisms. Maybe we need to increase diagnostic coverage of existing safety mechanisms. Or maybe we just need different components. By playing around with the numbers over here, we can then decide whether the metrics are good enough or not. So this, in a nutshell, is how we can use the FMEDA to check how robust a system